This is the 73rd lecture in the FOA lecture series on fiber optics. In this lecture, we're going to cover something different. We're going to talk about the history of fiber optics, how it got started, how it's developed, and where it is today. Let me introduce myself. My name is Jim Hayes, and I've been involved in fiber optics almost since the beginning. Actually, since 1978, it's been my profession full-time. First as an entrepreneur, and then also as an educator and writer. I'm also one of the co-founders of the Fiber Optic Association and have served as its president for many years. I've actually been around in fiber optics pretty much since it started. So as I go through and give this lecture, I'm going to talk about the details of our industry and how things happened. And along the way, I'll share some stories with you of things that I was involved with personally. We hope you enjoy our short history of fiber optics and how it's developed over the last 50 or so years. Going all the way back to the 1950s, there were a couple of events that make a difference in today's technology, but really predate fiber optics for communications. One was Narendra Kapani and Harold Hopkins separately used fiber optics to transmit images, like today's endoscopes. That doesn't have a lot to do with fiber optics for communications, but Kapani went on to have a long career of developing technology for fiber optics in communications. The one event that really makes a big difference in the technology is Abraham von Heel suggested cladding fibers to reduce attenuation. And that, of course, was very important in creating the low attenuation fibers we have today. In the early 1960s, Will Hicks and Elias Schnitzer at American Optical demonstrated transmitting laser light through an optical fiber. And that, of course, has lots of implications later on for how we do fiber optic communications. But the big event of the 1960s was when Charles Cow at Standard Telephone and Cables in the UK wrote a paper defining how optical communications could work. He got it right. He really defined how we use fiber optics for communications today. His work was recognized widely over the years, and eventually in 2009, he was awarded a Nobel Prize for his work. Well deserved. Of course, Dr. Cow's work was all theoretical. Then he left it up to others to figure out how to make it work. In 1972, Corning announced that they had made fibers that were low enough loss to actually be useful for telecommunications. The three guys here, Donald Keck, Peter Schultz, and Robert Marier, developed a new way of making glass optical fiber. Not by taking sand and melting it, but by building a preform from gaseous components that were so pure that the loss of the optical fiber was low enough to be useful for telecommunications. A few years later, 1977, the first field trials of fiber optic communication systems were done. In 1977, AT&T installed the first fiber link in Chicago. GTE was transmitting phone calls in Long Beach, California, and the British Post Office tested a link in the UK. And that's really where the beginning of fiber optic communications is marked. About the time they were installing those test links out in the field, I was invited to Bell Labs to see what they were doing in fiber optics. The company I was with made test equipment for AT&T, and they wanted us to make fiber optic test equipment. I got to meet all the people developing the technology, and my guide on my visit to AT&T Bell Labs was Tingy Lee, who later on became the head of the labs. It was a very interesting time because everything was developing extremely fast. After I visited Bell Labs a couple of times, I realized I had been there a decade before. When I was in the physics instrument business around 1970, I was there helping them with some work that I had done on integrated circuits. And I was working with the guys who were developing lasers, which in 1970 they demonstrated the first semiconductor lasers. That was awarded a Nobel Prize too later on. The 1980s were a really wild time in fiber optics. More development went on in this one decade than one can imagine unless you live through it. And I did. My company didn't want to build test equipment for AT&T, but I decided to do it myself. So in 1980, I formed a company called Photech that was one of the first manufacturers of fiber optic test equipment. Well, as I said, the 1980s was a period of very rapid development of fiber optics. The first long-distance networks were installed in the east and west coast in the U.S. and in other areas around the world. The first long-distance networks in the early 1980s were multi-mode fiber and 850 lasers. They were working on the idea of doing wavelength division multiplexing. So the fiber was designed to handle both 850 and 1300 nanometers. But the first 1310 lasers didn't become available until about 82 or 83. And with my contacts in Bell Labs and AT&T, I helped them build the equipment on which they manufactured those lasers. As a result, they sold them to me so I could build them into test equipment and sell it back to them. But those lasers cost us $3,500 a piece. And that's for a laser, a 1310 Fabry Perot laser, that you can buy today for under $10. The big thing in that era, though, was everybody knew they had to get away from multi-mode fiber and get into single-mode fiber. And there were three parts of converting to single-mode fiber. The first was the fiber, and it had to be made very precisely. The second part was the 1310 nanometer lasers, and the third part was connectors. Connecting two single-mode fibers was very difficult. The precision was more than connectors at the time could handle. The big change came with the introduction of the ceramic ferrule connector. And that, of course, is the connector that we use today. So right around 1984, all of these things came together. We had the fiber, we had the lasers, we had the connectors, we already knew how to splice fibers, we already knew how to make cables. So things really started taking off. In 1984, I was at the Newport Conference for Fiber Optics, which was a marketing conference every fall in Newport, Rhode Island, run by a guy named Jack Kessler. And at that conference, the technical director of MCI said that MCI was changing over from digital radio to single-mode fiber. And that marks the beginning of the new era, the current era of fiber optics. And interestingly enough, those 1310 lasers and that single-mode fiber And those ceramic ferroconnectors are essentially what we're still using today, almost 40 years later, which I find amazing. Of course, that was only the beginning. During the 1980s, the world started realizing we needed standards for fiber optics, and we began working with the EIA for their Standards Committee works in the early 1980s, around 1982. We also were working with the National Bureau of Standards, what is now called NIST in the US, to develop standards for measuring optical power, because our fiber optic test equipment needed that in order to be really useful in the market. Lots of other things happened. The first submarine fiber cable was installed, TAD-8, in 1988, which is amazing because that was like 5 years after the first terrestrial single mode went in the ground. It took more than 50 years for the first copper submarine cable to be installed. But with fiber, it was so much easier. TAD-8, installed in 1988, was still operating in 2002 when it was decommissioned because it had been replaced with many other submarine fiber optic cables. Fiber optics started also being used for local area networks. Ethernet was developed, and the first standards for fiber optics in Ethernet were developed. We also worked on a committee that developed Fiber Distributed Data Interface, the first 100 megabit per second fiber optic network, and it was strictly fiber. It wasn't copper, it was only fiber, unlike Ethernet, which was mostly copper. There were some interesting military developments during the era. There was a thing called FOG-M, a fiber optic guided missile. It was literally a missile with a spool of fiber in it. The fiber would string out behind the missile when it was shot, and a soldier with a joystick could control it remotely, looking through video sent back up over the fiber. Crazy idea, never really went anywhere, but it was a fascinating use of fiber. As I mentioned, I had started a company called Photech, which stands for the Fiber Optic Test Equipment Company. And during that decade of the 80s, we had lots of interesting things going on. We built equipment for AT&T to build their first 1310 lasers. We built equipment for manufacturers to do testing on connectors and splices for long-term durability. And one of our customers was Hughes Aircraft, who made a military connector. And when visiting one of their facilities, where we installed a big multi-channel test system, they showed me how they were using a helium neon red laser to trace fibers. And I remember having this conversation saying, wow, that would be a great field test instrument. But the laser they used was about 1.5 meters long, 5 feet long, and weighed about 100 pounds. And you certainly weren't going to carry that out in the field. Well, I was persistent, and I found that the people who made their lasers, another division of Hughes, made smaller lasers. And eventually I was able to find a small helium neon laser which we could package into a suitcase like you see in the picture here, and we created the first visual fault locator. And that was the invention of probably one of the most useful tools in fiber optics. And I'm sure you're familiar with visual fault locators today because, like that little one down in front of the big helium neon one, those things are inexpensive and the size of a laser pointer, and everybody has one. But that's how the VFL got invented. It was inside a lab at Hughes. In that same era, we had lots of other interesting projects. We built talk sets because before the era of cell phones, techs needed to be able to talk from one end of a cable to another over very long distances sometimes in the outside plant. So we built essentially a fiber optic walkie-talkie, which we call Photalk. And that was another product that was very, very popular until cell phones came around about a decade later. As I said, it was a very, very interesting, very dynamic era in fiber optics. The 80s were sort of the getting started decade. There was technology to develop, like single-mode fiber, lasers, and the ceramic ferroconnectors. There were networks to develop, like Sonnet, which was the first fiber optic telephone company network, which was in wide use until Ethernet displaced everything a decade later. So if the 80s was the era of developing technology, the 90s were the applications era. Basically, the technology existed, it just blew through the industry. The telecommunications industry spent tons and tons and tons of time and effort and money installing fiber optic communication systems. First in the long-haul networks, then by the mid-90s we were doing metro networks. And almost every city was full of fiber. The two things which really affected that era was the development of the internet and the World Wide Web, and the following market craze, which we call the dot-com boom. As soon as everybody realized how powerful the internet was going to be, everybody rushed to install all the fiber they could to support the traffic of the internet. And the dot-com boom, we call it, lasted until about 2001. And that was the craziest time you can imagine in terms of the amount of work that was going on to install fiber. There was technology being developed also. Fiber amplifiers and DFB lasers led to better long-distance networks, but they also made possible hybrid fiber coax cable TV networks. And that led to cable broadband. My company, Photalk, was actually involved in some of the very, very early field trials of cable modems, and I personally had a cable modem, one of the first, well, certainly the first 100 in the world, installed in February of 1997. And when you had been dealing with dial-up and 56 kilobaud modems for a while, a 4 megabit per second, always-on internet connection was an absolute miracle. February of 97. It's been that long, 25 plus years. The 90s also saw the beginning of dense wavelength division multiplexing, which combined with fiber amplifiers and DFB lasers, increased the capacity of an individual fiber tremendously. We also saw the beginning of data centers to service the internet. And believe it or not, in 1999, the term Internet of Things was coined. So the 90s was sort of the production side of developing fiber optics. It was an amazing time, but it wouldn't last. During the 90s, there was, of course, a lot of fiber optic installations going on, and there was a tremendous need for training fiber optic technicians. So during the 80s, I had already started training and involving other people in the industry in our training sessions. And in 1993, we actually started having conferences for fiber optic training, where we would have hundreds of attendees show up and 30 or 40 vendors show up. We'd take over a hotel for a week and we'd do a just crazy amount of training. It was a great time. You can see from the picture on the left there, Eric Pearson lecturing to a crowd of over 225 students at FiberU in Long Beach in 1993. And on the right, Dan Silver, who was one of the people behind the whole idea of FiberU, demonstrating a splice closure in the hands-on activities we did actually in a tent outdoors in Long Beach. In 1995, Dan and Eric and a dozen or so other of my instructors who came to teach at FiberU decided at lunch that it was time that the fiber optic industry had its own professional society. And so over lunch, we basically came up with the idea that became the FOA. In July of 95, we incorporated the Fiber Optic Association as a professional association for fiber optics, chartered to promote professionalism in fiber optics through education, certification, and standards. And of course, we're still going strong from 1995, 27 years later, in 2022. The other thing that transpired in that era was that I hired a high school teacher as an intern at Photech in 1997, and he showed us how to do online training using the internet. And FiberU Online went live in early 1998, certainly the first online training in fiber optics, and probably some of the first online training anywhere in the technical world. And of course, FiberU, very, very popular today. Now, what you might expect to hear is that the first decade of the 21st century was a continuation of the massive growth in fiber optics that went on in the 1990s. But it wasn't. 2001, the dot-com boom became the dot-com bust. It was basically because everybody had overestimated how fast the fiber optic industry and the internet was growing. And so way too much fiber got installed, and everybody realized there weren't any customers for it. Literally, the fiber optic industry decreased by 2/3 almost overnight. It literally evaporated. It went down to about 1/3 of the volume it was before. And lots of companies went out of business because they couldn't support the structures that they had built up during the dot-com booming era. But it had a different effect. The strong companies survived. The prices of fiber optic components declined a lot, almost 70% in some cases also. And that led to the next era in fiber optics, which was the development of fiber to the home. The two major elements in the development of fiber to the home were, as I just said, the cost of components going down, But secondly was the development of passive optical networks for fiber to the home. And I'll leave it to one of our other lectures for you to learn about passive optical networks. But that made it possible all of a sudden for telephone companies and others to consider connecting homes up directly on fiber optics. And that's what happened. The first major company in the United States to do it was Verizon. And that was in part because they had the oldest and least reliable copper network. We had a Verizon phone when we lived in New England, and it was running on cables that were installed 50 years, 60 years earlier. So those cables required a lot of maintenance. And it made it easier to Verizon to make that changeover into doing fiber. When Verizon started Fios, they came to the Fiber Optic Association, and we developed a training program for them. They wanted us to help them train and recruit the large numbers of people they needed to install fiber to the home. So we not only developed a training program, we actually had conferences on the East and West Coast to educate people about fiber to the home and to invite them to talk with the co-sponsors, the people from Verizon who were at the meetings, about working with Verizon to build out fiber to the home. And we know now how important that was, because fiber to the home now represents the majority of the business in fiber optics. There were really a couple of other things that came up technically during the era that have made a massive effect. The first one, of course, in 2007 was when Steve Jobs got up and introduced the iPhone. All of a sudden, the smartphone operating over a cell phone network and the internet started driving the traffic on the internet backbone crazy. And that required massive build-outs in fiber optics. The other technical development during the era that may be just as important as passive optical networks is the development of coherent fiber optic communications. Coherent fiber was a very difficult technical issue. But once it was solved, we now see it revolutionizing very long-haul communications, where it started going hundreds of gigabits per second for thousands of kilometers, to now being cost-effective for metropolitan networks and perhaps even data centers. It's something that we'll see more and more of as fiber optics carries faster and faster communications. From an application standpoint, submarine fiber optic cables were probably the most important thing. We had already done all of the terrestrial long haul in most cities, and now we were starting to connect fiber to the home. But the continents were being connected by submarine cables like crazy. And every time a submarine cable would get installed using new technology, it would double or triple or provide 10 times more communications. And it was that era with the submarine fiber optic cables connecting the world, over 400 of them today, that has made worldwide communications instantaneous, cheap, and ubiquitous. The last decade, 2010 to 2020, was really an applications decade. It really was a decade of fiber to the home, and in particular, gigabit fiber to the home. Chattanooga became the first gigabit city, but Google really made everybody aware of what gigabit unlimited bandwidth really meant for internet users. And Google really educated the world, and certainly America, where 1,100 cities vied to become a Google Fiber city. They really made everybody aware of what was going on with fiber to the home. On a technical side, the passive optical network technology used for fiber to the home was also adapted into optical LANs. Instead of using structured cabling, you use passive optical network, and you can build a local area network for half the price or less of a standard structured cabling network. And that's become a popular application. We saw the first terabit over a fiber network at a single wavelength with coherent communications. Toward the end of the decade, we had 5G cellular get introduced, terribly overpromised, and is still in the development phase now, almost 5 years later. Mainly because 5G cellular requires lots of fiber. Lots of fiber takes time to build and lots of money. So we're seeing it develop. On the fiber optic component technology, this decade also brought us micro cables and high fiber count cables, which were really solutions to a problem of we need more fiber. And how can we get more fiber into the ducts we have? And those two, of course, have become very important in getting more fiber to the users. And that brings us basically up to the current time. This decade has probably mostly been affected by the pandemic, with people working and learning from home, shopping from home, doing everything from home on the internet. It's really showed the importance of having broadband. And that importance has worked its way up to the top, so that, like the U.S. government is promising billions of dollars for funding broadband expansion, and their documents for broadband expansion say it's going to be fiber optics. 5G is still there, but some of the promises of 5G haven't paid off yet, and I take a more wait-and-see attitude. It still requires a lot of fiber, but it hasn't really proven to be all that effective at connecting homes. If you're going to connect a home, it's going to be fiber. What's the future going to be? I'm not guessing. There's too many possibilities. But the one thing we know is whatever the future is, it's going to require more bandwidth. And more bandwidth means more and more fiber. So whatever happens, we're going to see a lot more fiber. So that's it. That's the history of fiber optics in about 37 minutes. It's sort of like a podcast with a slideshow, right? We've developed a timeline at the Fiber Optic Association, and if you go to foa.org/timeline, you can see what we've talked about here with even more detail. And it's interesting. And I am really pleased to have been part of the development of this industry, and I am even happier to be able to say that I could share it with you. So I hope you've enjoyed this, and I hope you enjoy being part of the fiber optic industry, just like me. We're the Fiber Optic Association, the International Professional Association of Fiber Optics. We also have FiberU, our online learning site, and the FOA guide with more than 1,000 pages of technical information. The FOA is a nonprofit organization set up by the industry to benefit the industry. And as I said, when we founded the FOA, we said we were chartered to promote professionalism in fiber optics through education, certification, and standards. And that's what we do.